Hi there. So in this section, we're going to look at solving rational and radical equations. We'll start the notes off by just focusing on solving rational equations. I have at the top here listed for you the steps for solving a rational equation. The first thing you're always going to do is find the LCD, your least common denominator, and then you're going to multiply the entire equation, every single term, by that LCD to get rid of your fractions. Then you'll solve it. And the key thing that you need to keep in mind here is that you're going to need to check your solutions into the original equation when you're solving these rational equations, because it is possible when in the solving process for you to come up with an answer that's actually not a legitimate answer. For example, if you come up with an answer that would make the denominator equal to 0, then that would not be a legitimate answer to the equation. So it's always important that you go back and substitute in the answers that you get to make sure that they are true solutions to the equation. And I'll illustrate that for you here in the notes. I've got it set up that we're solving rational, and then we'll solve radical on the back half of this notes. So for the rational equations, I believe I have 4 examples here for you. I'm going to work 2 of them with you, and then let you consult the solution key for the other 2. So let's look at number 1 and number 3 here together. So if I'm utilizing my steps that I have written out here for you, it says, okay, when you have your rational equation, you want to find your LCD, the common denominator. So just looking at our 2 fractions here, well, I can just multiply by my common denominator, which would be nothing more than taking these 2 denominators, existing denominators, and multiplying them times itself. So my common denominator would be x minus 1 times x plus 2. And so what happens is when you take this common denominator and multiply it times this first term over on the left-hand side, the x minus 1's go away, and you're going to be left with 2 times x plus 2. Then when you take this same denominator and multiply it times the right-hand side, this time the x plus 2's go away. You still have the x minus 1 though, because it's back in play, so then this equals 3 times x minus 1. And now this is very straightforward from here, which should be a matter of now that we are distributing, combining like terms, moving items from one side of the equals mark to the other, so that our ultimate goal is that we get letters on one side, numbers on the other. So let's go ahead and do just that. Let's distribute. So on the left-hand side, 2 times x, 2x, 2 times 2 will give us 4. On the right-hand side, 3 times x, 3 times negative 1, so minus 3. I like to do my letters next, so between 2x and 3x, this 2x is the smallest, so I'm going to take it to the other side by doing the opposite. So since it's a positive 2x, I subtract 2x from both sides. Cancels out, so now I have 4 equals x minus 3. Last step to get x all by itself, add 3. So x equals positive 7. So I have solved it now. Letters on one side, numbers on the other. So x equals 7. And then as I mentioned to you, you have to go through the check process to make sure that 7 is indeed a solution. So I'll just show this here. Here's our check. Then I go back to my original equation, and everywhere I see an x, I'm plugging in 7. So I have 2 over 7 minus 1. And I'm trying to see, does that equal 3 over 7 plus 2? Okay, so over here on the left, I have 2 over 6 now. On the right, I have 3 over 9. If you reduce these fractions, 2 over 6, you can divide them both by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. On the right-hand side, this can also be reduced. 3 goes into both of those. Divide them both by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So sure enough, x equals 7 is a solution, and it's the only solution. So that is x equals 7 is your solution. Okay, I'll let you pause the video and try example 2 now on your own. Let's scoot on down and look at example 3. In example 3, the only difference here is that the function itself is a little more involved, but nevertheless, it's still the same technique. The only thing I would do first of all in number 3 though is that I would look at the denominator on the right hand side, that x squared minus 16. I would go through and I would factor that so that you see that you have x over x minus 4 minus 4 over x plus 4 equals right hand side 32. And if you factor that, it's a difference of squares, right? So x plus 4, x minus 4. So we can see then when it comes time to now create my common denominator, my common denominator can then be, again, just my denominators, x plus 4, x minus 4, and I don't have anything new to pick up over here. So I'm going to multiply everything by x plus 4, x minus 4. So when I'm doing this first term, I know that denominator of x minus 4 is going to cancel out, so I'm going to be left with x times x plus 4. Next term, I'm going to bring down my negative 4. This time the x plus 4's cancel out, so I'm left with x minus 4 equals, and on the right-hand side, when you multiply by the common denominator, the full denominator cancels out, and you're just left with 32. All right, so now from here, let's distribute. So x times x squared, x times 4 plus 4x. Let's distribute a negative 4 now, so minus 4x plus 16 equals 32. Let's clean up a little bit further. In the center here, what happens to those 4x's? Hopefully you agree. One's positive, one's negative, and they're the same numbers, so they are going to cancel out. So that's going to collapse down and give me x squared plus 16 equals 32. My goal is to solve for x, so I can just pull this 16 over, subtract 16. X squared equals 16. To get x all by itself, how do you do that? Hopefully you agree. Just take the square root of both sides. Square root of x squared, just x. Square root of 16 is 4. And technically it's plus or minus 4, so we need to go ahead and put that because, right, if we took positive 4 and we squared it, we get 16. And if we took negative 4 and we squared it, we would get 16. So x equals plus or minus 4. Now, if we come back and go back to our original equation to do our check, it's a little bit smaller so I have enough room. Our equation was this: x over x minus 4 minus 4 over x plus 4 equals 32 over x squared minus 16. And we're saying right now that we have possible answers at 4 and negative 4. If at any point you can plug your number into the function and it makes a term undefined, then it's automatically out as being a solution. So straight away, when you put this positive 4 into the first term, you end up with a 0 in the denominator, and so NO can't happen. You cannot have a 0 in the denominator, so we already are knocking out positive 4. If you try negative 4, it works in the first one, right? Negative 4 minus 4, so we could clean that up. But when we go to that second term, when I do negative 4 plus 4 here, that denominator now turns to 0 on me. And so negative 4 is not a solution either. And so even though we were able to go through the solving process here and find solutions, they are not solutions to this equation. So therefore, we say that this equation has no solution. That's why it's imperative that when you're solving these that you go back and do the check, okay? So hopefully you get to see that. You definitely get to see that here in this example, and you'll get to see it again in the next example, all right? So I encourage you to stop and try that next one before you move on. But here in the video, I am going to go on, flip it on over, next page. Now we're looking at solving radical equations. And so with solving radical equations, again, the first thing you're going to do is you want to isolate the radical. You're going to raise it to the appropriate power to get rid of that radical. So meaning if it's the square root, you're going to square it. If it's the cube root, you're going to cube it. If it's the fifth root, you're going to raise it to the fifth power. So that's what we mean by appropriate power. Okay, so whatever root it is, you raise it to that power. You'll solve, and then here again, you have to check your solutions into the original equation. So usually the hang up with rational expressions that we just looked at was that you can't have zeros in the denominator. With radical equations, you cannot take an even root of a negative number, okay? So always make sure that when you substitute back in, that your answers again make sense. And then I have an extra note down here for you. If there is more than one radical, meaning more than one, for example, square root, when I say radical, we're talking about some kind of root, a square root, cube root, and so on. Isolate the more complex radical first, and then repeat steps 1 and 2. Okay, I'm going to illustrate that for you down here in example 7. So I plan to do example 5 and example 7 with you, unless you do example 6 with the solution key. Okay. All right, so let's get back to solving here. We are looking then at example 5, solving this radical equation. And according to step 1, I have to isolate the radical first. That means I need to isolate whatever kind of root I have here. So in this case, I have a square root. So it's got to be all by itself. That means that I need to take this 1 to the other side. When you cross the equals mark, do the opposite. So subtract 1. So now I'm left with the square root of x plus 1 equals x minus 1. Then step 2 says raise it to the appropriate power. So since this is the square root, I'm going to square both sides. All right. So now on the left-hand side, anytime you take a square root and you square it, or any root raised to its power, you always get what's inside. So that's just going to give me x plus 1. On the right-hand side, this x minus 1 squared, remember that x minus 1 squared really means x minus 1 times x minus 1. That little 2 up top means to write it twice so that you can FOIL this. So if we start FOILing here, x times x squared, outside negative 1 times x, negative inside negative 1 times x, last negative 1 times negative 1. All right, let's start cleaning up over here. X squared, negative x, and negative x. Remember, those are imaginary ones there, so minus 2x plus 1. And now from here, our goal is to solve for x, so we need to get all of our x's all together. Since your x squared is over here on the right-hand side and it's already positive, I'm going to bring the x plus 1 to the right-hand side. And you cross on the equals mark, so do the opposite. So subtract x, subtract 1. So that cancels out here. We're left now equal to 0. X squared minus 3x, and my 1's cancel out. Now from here, we're trying to solve for x. You'll notice these two terms have something in common. They both have an x in common. So factor that x out. So I have x parentheses, x minus 3. Set both of those terms now equal to 0. So I set x equal to 0 and x minus 3 equal to 0. And I solve for x. So this one's already solved. X equals 0. In the other scenario, I have to add 3. So now we know that x equals positive 3. So these are two possible solutions. I need to determine if they are indeed solutions. That's where the check comes in. So to do our check, remember, go back to your original equation. It was the square root of x plus 1 equals x. So if I plug in 0, then I have the square root. I'll just show all my work. Just trying to see, okay, what does that equal? 0. So the square root, 0 plus 1 is just going to give me 1. So I have the square root of 1 plus 1. Square root of 1 is 1. So 1 plus 1. Well, hopefully you can already kind of see where this is going. 2 does definitely not equal 0. So x equals 0 is not a solution. So I'm going to exit out. That is not a solution. Let's try x equals 3. So the square root of, I'll write my problem again. It's x plus 1 plus 1. I'm trying to see, does that equal x? Everywhere I see an x, I'm plugging in 3 now. So 3 plus 1. And does that equal 3? Square root 3 plus 1 we know is 4. Square root of 4 is 2. 2 plus 1. Sure enough, this is starting to look good, right? 3 equals 3. That's a true statement. X equals 3 is your one and only solution. So that is your only solution here. Okay? X equals 3. All right, so the only thing different in number 6 is that it's being raised to the, when you first start out, your cube root here, your radical is already isolated, so you don't have to isolate it like we did on the first one. And since it's isolated, now you're ready to get rid of it. But since it's the cube root, what are you going to raise both sides to? Hopefully you agree, the third power. So you'll be raising both sides to the third power. And just go from there, follow the solution key. I think all my steps are there for you to follow along. Let's move on down to example 7 then. And just so you can see how what happens whenever you have multiple radicals within one equation. And as the directions up at the top told you, is that if you have more than one, try to isolate the one that is more complex. And so between the square root of x and the square root of x minus 5, well, the square root of x minus 5's got a little bit more going on, so I would isolate it. first. So in isolating that term first, that means I'm going to take the square root of x to the other side. So I'll subtract the square root of x. So I have negative square root of x minus 5 equals 1 minus square root of x. Now from here, probably the best thing to do is let's get rid of this negative in front of the square root. So we'll divide by -1. And whatever you do to one side, do to the other, do it to every term. So this now leaves me with the square root of x minus 5 equals -1 plus the square root of x. Now, just like you saw before, you've got your square root now here isolated, so you're ready to get rid of that square root. You're going to raise both sides to the second power. Since it's a square root, raise it to the second power. Anytime you square a square root, you just get what's inside, so that's just going to be x minus 5 over here. On this right-hand side, just like you saw in the last problem, this really means now -1 plus the square root of x times -1 plus the square root of x. So we've got to FOIL this. -1 times -1, +1. Outside, -1 times the square root of x, so minus square root of x. Inside, same thing. Last, square root of x times square root of x, just give you x. All right, let's clean up that right-hand side. So I have now 1 minus 2 square root of x plus x. Okay. Now from here, we need to isolate again the next square root, okay, or the next radical, okay, depending on what, how the problem's structured, but this one has all square roots in it. So that means I need to take the 1 and the x to the other side. So I will be subtracting 1 and subtracting x. Subtract 1, subtract x. So that way over here on the right-hand side, they're canceling out. I'm left with -2 square root of x. On the left-hand side, the x's cancel out, and I have -5 and -1. That gives me -6. Next step, to get this x all by itself, divide by -2. So I have square root of x equals +3. Last step, get x all by itself, square both sides. 3 squared, of course, is 9. Square root of x squared is just x. So x equals 9. Let's do our check to see if 9 really is a solution. So coming back to your original problem, I'll write it down here for us, minus square root x minus 5. Trying to figure out, does that equal 1? So everywhere we see an x, we're plugging in 9. Square root of 9, of course, is 3. Down here I have 9 minus 5. That'll give me the square root of 4. So then I'll have 3 minus square root of 4 is 2. And sure enough, 3 minus 2, 1 equals 1. That checks out. So x equals 9 is a solution to your equation. Okay? All right, let me know if you need anything. Thanks a lot. Bye.